And I'm going to share my screen. And oops, I meant to finish doing this and didn't. Give me just half a second. And let's share this. Today we're going to look more at the quadratic formula, and we're going to start looking at other equations. The assignment that's due tonight, 1.5, I'm sorry, not due tonight, is due Wednesday, is on using the quadratic formula. I think we had last class said that we had gotten through questions 1 through 20 on that, and we would look at the rest of them today. And then 1.6, that next assignment is on solving other equations. We'll do probably not quite half of that today. Does anybody have any questions? Has anybody started looking at homework 1.5 or any of the assignments before then and wants to look at any of those problems?
I'm good.
Good. Anybody else have a question? If not, in terms of the quiz over the weekend, some of you did not do it. You need to get a hold of me about that. Some of you did it and did not submit your work in Blackboard. If I did not get work from you in Blackboard, I sent you an email. Please respond to that, because again, I am not going to grade it and put the grade in the Blackboard grade book until I see your work. The homework grades count in the MyLabs grade book. I just bring over the homework average periodically. But in terms of the quizzes, the MyLabs grade book is not weighted to include the quizzes. I need to transfer them into the Blackboard grade book, and I want to see your work before I do that, so that I make sure that you do them. For most people, my looking at their work gives them extra credit because I give partial credit. I think so far this semester, there have only been 2 people where it had the opposite effect. And what made me think that those people were not doing their own work, but rather somebody else's, is the problems in their work was different than the questions that they were answering. Made me think that there was probably a little bit of copying going on there. And we'll leave that at that. But if nobody has any questions, Florida,
I do.
Does this sound better?
Yeah.
Okay, Elise, what did you want to do?
I do have a question about the quiz, but can I wait till after class?
No, you can ask now. Which problem?
No, it wasn't like a problem. It was just about the quiz in general.
Okay, all right, then we'll talk about that after class, okay?
Okay, thank you.
All right. So to this point, we've been solving quadratic equations. And we had defined a quadratic equation as being a second degree equation. In terms of solving quadratic equations, we said we could solve by factoring and using the zero multiplication property, which says that if I make one side 0 and factor, we can then set the factors equal to 0, because the only way I can get a product of 0 is if one of the things I'm multiplying is 0. We said we could use the square root property. And the square root property said that if I have a quantity squared equaling a constant, I can take the square root of both sides and get that it can equal plus or minus the root of the constant. And remind me at the end of class to add you to attendance. We could solve by completing the square. Which turned a problem that was not in the form of using the square root property into one where we could. by adding a constant to a binomial, giving us a perfect square trinomial. And then we looked at the quadratic formula. And I think with the quadratic formula, we started with a standard form equation. Oh Lord, how do you spell standard? Which was ax squared plus bx plus c equals 0, where one side's 0 and it's in descending order. And we got the formula that the solutions would be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if I remember correctly, on Friday, we spent a little bit of time completing the square with that standard form and showing where that equation came from, but we didn't use it. So let's look at some examples where we're going to solve using the quadratic formula. And show some examples of its use. And let's start with x squared plus 13 equals negative 4x. When I go through and do this, first thing that I want to do is I want to put it in standard form. And by standard form, one side is 0. And the other side in descending order. So can everybody look at this equation and see that we do not have one side 0? Which would you folks rather make 0? The left or the right?
The right.
How would you do it?
You would just add 4x to the other side, positive 4x.
We'll add 4x to both sides. Beautiful. That gives me 0 on the right. And then when I do the left, I want to make sure that they're in descending order. Is everybody all right? Descending order means those exponents go down and my constant term is last. Then the next thing that I want to do is I want to identify A, B, and C, which are just the coefficients. I know some people like to write underneath ax squared plus bx plus c equals 0. And so A is just the coefficient on x squared. As I look at my x squared term, what's the number in front? What am I multiplying x squared by if there is no coefficient written? Does everybody see the little invisible 1 in front? So that A is 1. B is the coefficient on x. The number in front of x is 4. C is the constant term. Our constant term here is 13. Please, 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 please. One of the most common careless mistakes that I see with these is that people identify A, B, and C as something other than the coefficients. A, B, and C should always just be numbers, should not have any variables left. I'm not looking for the variable part, I'm just looking for the coefficients. Now I'm going to write the formula. And hopefully everybody's had time over the weekend to memorize this one. X equals negative b plus or minus the root of b squared minus 4ac all over 2a. Then I'm going to substitute my given values for a, b, and c. So that's going to give me x equals b is 4, so that's negative 4, plus or minus the square root of b is 4 squared minus 4 times a is 1, c is 13, all over 2 times a is 1. Is everybody comfortable with that substitution step?
Yeah.
Then we'll simplify. And so order of operations, I start inside. Inside the symbol of grouping, the radical, I have 4 squared minus 4 times 1 times 13. So what's that? That's 16 minus 52. So everybody write that's negative 36. So we've got negative 4 plus or minus the root of negative 36 over 2. And then remember, if I have a negative under the radical, I have a negative radicand, we have to get an imaginary number. So when I look at the square root of negative 36, that's 36 times negative 1. So that gives me 4 plus or minus 6i over 2. So separating, that's 4 plus 6i over 2, 4 minus 6i over 2. We want to make sure we go through and put that in standard form. And so,
Negative 4.
yes, it is. Thank you. Somehow I lost that negative sign. So that gives me negative 2 plus 3i and negative 2 minus 3i. Usually they ask you to put them in that a plus bi form. You want to separate the real part from the imaginary part, break it into 2 fractions and reduce them, and take the coefficient off of I. How'd that look? Not hearing any complaints, I'm going to ask you folks to do one. This time I'm going to ask you to solve using the quadratic formula. And I'm going to look at x squared. Whoa, what happened there? X squared plus 6x plus 8 equals 0. And this one's not too bad because it's already in descending order for you. How's everybody doing? Did everybody get A is 1, B is 6, C is 8? Giving us negative 6 plus minus the root of 6 squared minus 4 times 1 times 8 over 2 times 1, which simplifies to -6 plus minus the root of, what is it, 36 minus 32 is 4 over 2. So we get x equals -6 plus 2 over 2, and x equals -6 minus 2 over 2. And so -4 over 2 is -2. -8 over 2 is -4. And those would be my solutions. How'd you folks do?
Pretty good.
Good. If that's all right, let's look at a couple that are a little bit different. Next example. Let's look at 2x squared equals 250. If I want to solve using the quadratic formula, first thing we need to do is what?
Divide both sides.
We could divide both sides. Not essential, but that's all right if you want to. That would give me x squared equals 125. And then if I want to use that quadratic formula, as opposed to the square root property, then I'd have to subtract that 125 from both sides, giving me x squared minus 125 equals 0. If I compare that to ax squared plus bx plus c equals 0. And I know you could solve this one using the square root property, but I wanted to look at an example where we had a binomial and not a trinomial to make sure that everybody was comfortable in identifying that A, B, and C. A is the coefficient on x squared. We have an x squared term. Its coefficient is 1. C is the constant. We have a constant. It's -125. B is the first degree term. Do I have a first degree term? Is there a plain old x term in that binomial? No. Is everybody comfortable? If that term is not there, that coefficient is 0. And so now when I substitute into x equals -b plus minus the root of b squared minus 4ac all over 2a, it gives me -0 plus minus the root of 0 squared minus 4 times 1 times -125 all over 2 times 1. And be careful. Please remember that it's that whole thing over the denominator. That gives me 0 plus minus the root of negative times negative is positive. 4 times 125 is 500 over 2. And now I have to look at that square root of 500 and simplify it. Does everybody see that 100 is a perfect square that goes into there 5 times? That gives me 10 radical 5. And so what we did earlier in simplifying radicals is something that we need to be able to work with now. So that gives me 0 plus 10 radical 5 over 2, or 0 minus 10 radical 5 over 2. And so my solutions are 5 radical 5 or -5 radical 5. And again, what I was looking for with this example was I wanted to make sure that everybody was comfortable solving if I had a quadratic with only 2 terms. The coefficient on the missing terms would be 0. How's that one? Any questions? If not, are you guys ready to try another?
Yes.
So next example, let's solve using the quadratic formula. And let's look at x squared plus 17 equals 2x. And so I'm going to ask, help. What would you folks do first with this one?
Move over the 2x.
Okay. So let's subtract 2x from both sides. Now be careful, we want to make sure that the non-zero side is in descending order. So how should I write that?
X squared plus 2x plus 17.
Be careful with your signs though.
Oh, yeah,
That's
sorry.
the type of thing that I do all the time. So minus 2x, all right? And so now if we compare that to ax squared plus bx plus c equals 0, a would be 1, b would be -2, and c would be 17. And we're going to substitute that into x equals -b plus minus the root of b squared minus 4ac. And again, it's all over 2a. Negative of -2 plus minus the root of -2 quantity squared minus 4 times 1 times 17 over 2 times 1. Double negative makes it a +2 plus minus the root of. What do you get under that radical when you simplify -2 squared minus 4 times 1 times 17? Anybody get an answer there? Nobody? I believe it becomes -64 over 2. So now separating, I get x equals 2 plus 8i over 2, or 2 minus 8i over 2, giving me 1 plus 4i, or 1 minus 4i. I want to stop for a second and look at those two complex solutions. Does anybody notice the relationship between 1 plus 4i and 1 minus 4i?
Wait, isn't it the same thing? Because isn't I like a negative?
I is defined as the square root of -1. So one has positive I and the other has negative I. But do you remember
Oh,
what
I was
they
thinking of
did?
I squared, my bad.
That's okay. Do you remember when we've got the same terms, but one's a plus and one's a minus? We call that a conjugate pair.
Yeah,
Is-
that sounds familiar.
Does anybody remember that those are conjugates, complex conjugates? And if any of you are on this math train long enough to be going through pre-calculus, you're going to find out that if my original equation has all real coefficients, if I have an imaginary root, its conjugate must also be a root. Those complex roots come in pairs. So something that's interesting. And then another thing that I think we might have talked about earlier, does everybody remember that we said that if it's second degree, degree tells me how many roots to look for so that I get 2 roots. And I don't know if we started using that word roots before. It's just a fancy pants way of saying solutions. And so that the degree of the equation gives us an idea as to how many solutions we have. And again, when I look at my original equation, if they're all real numbers, all real coefficients, then if I get one complex root, I should expect the conjugate as the other one. So let's see. Did we do 4 of these? I believe so. Any questions at all on this quadratic formula? Again, it's something that you need to know.
Can
It's
you
a-
go through negative 64? Cause I just don't have my graphing calculator on me right now.
Okay. All right. So finger and toe math. When I look at that -2 squared minus 4 times 1 times 17. When I square a negative, I get a positive. 4 times 1 is 4. 4 times 17 is 68. And 4 minus 68 is where that -64 came from. All right.
Thank you.
Believe it or not, back in ancient times, we had to be able to do these without a calculator. So don't feel like it's not possible if you don't have your calculator with you. All right. So everybody feeling comfortable with this quadratic formula? Again, when it comes to the tests, and when it comes to Math 111, you're expected to know it. It's something that you need to have memorized. I like to joke that you need to be one with that formula. I need to be able to call you in the middle of the night and wake you from a deep sleep and ask you what's the quadratic formula, and you need to answer x equals -b plus or minus the root of b squared minus 4ac all over 2a. You just need to know it. All right. If there are no other questions, then the next thing that we're going to do is we're going to look at section 1.6, which involves solving other equations. And when we go through and look at solving other equations, the first thing we're going to look at are higher degree equations. And when I talk about higher degree equations, I mean above second degree. Because we just went through and came up with a whole bunch of ways of solving those second degree or quadratic equations. And so we're going to be looking at equations with exponents higher than 2. We're going to again find that the degree of the equation is how many roots we should have, how many solutions we should have. If we're looking at higher degree, and I apologize, I lost a word in there, polynomial equations. And so let's start by looking at an example. Let's say I have 2x to the third plus 3x squared equals 8x plus 12. And so before I go any further, how many solutions do you guys think this equation should have?
3.
3, because it's third degree. Beautiful. In order to solve, the first thing we want to do is make one side 0. And we usually want to put the other side in descending order. Which side we make 0 is strictly a matter of personal preference. Did you guys want to make the left side 0, the 2x cubed plus 3x squared? Or did you want to make the right side 0, the 8x plus 12? Anybody have a preference?
Make the right side 0.
Okay, and so we do that by subtracting 8x and 12 from both sides. I'll do the hard side. What's on the right is now 0. On the left, do I have any like terms? No, the exponents are all different. So we'll have to write that in descending order, 2x to the third plus 3x squared minus 8x minus 12. And then in order to finish solving this, we've got one side 0. So we're going to eventually use that 0 multiplication property, saying that if a whole bunch of things multiply to 0, one of them must be 0. And so once we've got that side 0, we need to factor completely. Oh boy. Recently, when we've been factoring, we've only been factoring binomials, 2 terms, or trinomials, 3 terms. This thing has 4 terms. Can anybody remember what we said we would try to do first in order to factor a polynomial with 4 terms?
See if they all have something in common.
Okay, is there anything common between 4? Pardon?
No.
No. Oh, crap. So if there isn't something in common between all 4 of them, and there are 4 of them, can anybody remember what we did?
Is it factor by grouping?
Beautiful. Factor by grouping. There's nothing in common to all 4 of them. Remember, we put a line down the middle and we split it in half. And we looked at it 2 at a time. So is there anything in common between 2x to the third and 3x to the second? Do they have any common factors?
X squared.
Beautiful. When I factor that x squared out, I'll be left with 2x plus 3. Same way, we now want to look at the last 2 terms, the minus 8x minus 12. Is there any common factor between negative 8x and negative 12?
Negative 4.
Beautiful. We're going to take out that factor of negative 4, and it should be negative if both of them are negative. And dividing by negative 4, we get 2x plus 3. At which point I'm smiling a little bit because I notice that they have that common factor. So one factor is, pardon me, 2x plus 3. And the other factor is x squared minus 4. Am I done yet, though? Or can I factor more?
You can factor more.
How?
You set them equal to 0.
We're going to eventually set them
Oh,
equal to
no,
0.
I'm too far ahead. Sorry
Yeah,
about
but how does x squared minus 4 factor?
that. X plus 2 and x minus 2.
Beautiful. And so now I'm factored completely. Now, I'm going to put a fancy name to it. We're going to use the 0 multiplication property to set each factor equal to 0. So you're just a step ahead of me. So now I've got 2x plus 3 equals 0. X plus 2 equals 0. And x minus 2 equals 0. And now we've got 3 smaller equations that I think we probably ought to solve. So let's say we solve the resulting equations. So in the first one, I'll subtract 3 from both sides, giving me 2x equals negative 3. And then dividing by 2, I get x equals negative 3 halves. Next one, we'll subtract 2 from both sides and get x equals negative 2. And finally, we'll add 2 to both sides. And we'll get x equals 2. And so you see we got 3 distinct solutions. If you were to do a check, you must check each solution in the original equation. And so for this, I would need to do 3 checks. My original equation was 2x cubed plus 3x squared equals 8x plus 12. And so if x equals 2, I get 2 times 2 cubed plus 3 times 2 squared. And I'm hoping that that equals 8 times 2 plus 12. Let's see. 2 cubed is 8 times 2 is 16. 2 squared is 4. 3 times 4 is 12. 16 plus 12 equals 16 plus 12. So it checks. Next, if I check my x equals negative 2, I have 2 times negative 2 cubed plus 3 times negative 2 squared. Does that equal 8 times negative 2 plus 12? Well, this is 2 times negative 8 plus 3 times 4. So what is that? Negative 16 plus 12 is negative 4. And this one is negative 16 plus 12, or negative 4. So it checks. Lastly, I have x equals negative 3 halves. So does 2 times negative 3 halves cubed plus 3 times negative 3 halves squared equal 8 times negative 3 halves plus 12. Let's see, this becomes 2 times 27 over 8, which gives me 27 over 4, plus 3, and this should be negative, by the way. Getting sloppy here, sorry. That should be 3 times positive 9/4, which gives me 27/4. So that's side 0. Here, this would give me 8 times 3 is negative 24/2, plus 12 is negative 12, plus 12 is 0. So that one checks. And so if you're doing checks, you need to check all of them if you're asked to do a check. How's that one look? Factor completely and set each factor equal to 0. Before you factor though, you must first make one side 0. Let's look at some more. Let's look at 4x to the 4th is equal to 12x squared. Does everybody see that this one is 4th degree? So I should expect 4 answers. And again, I always want to start by making one side 0. So which side do you folks want to make 0? The left or the right?
The right.
Okay. So let's subtract the 12x squared from both sides. Gives me 4x to the 4th minus 12x squared equals 0. Now we're going to factor. Whenever we factor, what should we look for first? Is-
Yeah.
What is the GCF? Any number going to both 4 and 12 evenly.
4x squared.
4x squared, beautiful. And when we factor that out, what are we left with?
X squared minus 3.
Beautiful. Now, neither of those factor further. So we're going to set each to 0. Gives me 4x squared equals 0. X squared minus 3 equals 0. I think on the left, I'm going to divide by 4 first, giving me x squared equals 0. And then when I use that square root property, I get 2 roots of 0, positive 0 and negative 0. But wouldn't those both turn out to be 0? And so over here, while it looks like there's just one answer, x equals 0, technically there's 2. You wouldn't have to write the second one. There's no need to write it twice. If you're on this math track through pre-calculus, you'll find that that's called a double root, something that comes from 2 factors that are the same. But now this one over here, this equation on the right, to solve x squared minus 3 equals 0, that does not factor. And since that does not factor, I have no idea why that extra thing popped up. Let me see if I can get rid of it. Let's add 3 to both sides, giving me x squared equals 3. And now let me use my square root property. Taking the square root of both sides, I get x equals the positive square root of 3, or the other one would be the negative square root of 3. And so this one, technically there's 4 solutions, but in practical terms, it really looks like there's just 2. How's that one for everybody?
It looks all right.
Okay. Next one's a little bit more challenging. Next one, let's look at 3x to the 4th is equal to 81x. I'm going to be quiet for a couple minutes. Let you guys work on this. Let's say 2 minutes. Did everybody start by making one side 0 and get 3x to the 4th minus 81x equals 0?
Yeah, don't you take out an x next?
How about not just x, but 3x?
Yeah.
Leaving me with x to the 3rd minus 27. But now this part here, x to the 3rd minus 27. Can anybody remember how to factor that? It's 2 terms. It's subtraction, but they're not perfect squares. Because that's x cubed, let's look at that 27. Is 27 a perfect cube? Is there a number that I can multiply by itself 3 times to get
Yeah.
27?
3.
That's x cubed minus 3 cubed. Once you recognize that's the difference of cubes, you have to remember the pattern for the difference of cubes. A cubed minus b cubed. Remember, it's the difference of what I'm cubing. And then that other factor is a squared, opposite sign, plus the product, ab, plus always the last one squared. And so that part would factor into x minus 3 times first term squared, x squared, plus the product of the two, 3x, plus the last one squared, 9. When I look at this second term is not factorable. So we've got this thing factored as much as possible. So let's set each factor equal to 0. And we've got these 3 equations to solve. First one isn't too bad. How would you solve 3x equals 0?
X equals 0.
Dividing by 3, we get x equals 0. So one of our solutions is 0. Spot on. How would you solve this second equation? X minus 3 equals 0.
X equals 3.
Beautiful. We'll add 3 to both sides. And that gives me x equals 3. Now, how do we solve this third one? X squared plus 3x plus 9 equals 0. Any ideas?
Quadratic formula.
Beautiful. It does not factor, so let's use the quadratic formula. I guess if you really wanted to, you could complete the square, but most people prefer to use that quadratic formula. If I look at that as ax squared plus bx plus c equals 0, what would you tell me a is equal to? Coefficient of
1.
1. Beautiful. B is,
3.
and C is
9.
1. Now, what is their formula? X equals something long and drawn out, and it's got a fraction in it and a square root in it. Can anybody remember how to fill in the other pieces? Nobody's volunteering. Hot to. X equals negative b plus or minus the root of b squared minus 4ac all over 2a. So when I substitute, that's negative b is 3 plus or minus the root of b is 3 squared minus 4 times a is 1 times c is 9 over 2 times a is 1. Gives me negative 3 plus minus. When you take 3 squared minus 4 times 1 times 9, what do you get?
9 minus 36.
And 9 minus 36 would give me negative 27 all over 2. So let's separate that into x equals negative 3 plus the square root of negative 27 over 2. And x equals 3 minus the square root, I'm sorry, negative 3 minus the square root of negative 27 over 2. And now the work we have to do is crack paper is the square root of negative 27. It's negative, so I'm going to have a negative 1 there. So when I take the root, I'll have an I. But can anybody think of a number that goes into 27 evenly that is a perfect square?
Nine and 3.
Beautiful. So that's the square root of 9 times 3 times negative 1, which gives me 3 radical 3i. So I get x equals negative 3 plus 3 radical 3i over 2. And x equals negative 3 minus 3 radical 3i over 2. So separating the real part, we get negative 3 halves plus, separating out the coefficient, 3 radical 3 over 2i, or negative 3 halves minus 3 radical 3 over 2i. And so this time we do have 1, 2, 3, 4 distinct solutions. 2 of them are complex, and the coefficients on the 2 complex ones are, the 2 complex roots, pardon me, are conjugates. So I'm looking at the rest of that section, 1.6. And I'm thinking that the next section is a little bit more involved. This was where I ended in the 11 o'clock class. Do you guys want to keep going into the next section, or shall we call it a day?
Good with calling it a day here.
Okay. Anybody else have a problem if we call it a day?
No.
No. All right, then I'm going to stop sharing. I'm going to stop recording. And